Hi everyone, welcome to the final video for section 4.4. Hopefully you've had a chance to look over the two questions in the guided notes that you'll see here on this video. If at any point you were working on those problems and you did hit some challenges or roadblocks, please don't worry. The main goal at this point is to make sure that you feel comfortable starting the problem. So if you did experience any sort of challenge or you're not certain about your solutions, please feel free to make sure that you have some extra paper near you, some graph paper maybe, some highlighters, and then we're going to go through these. Make sure that you're taking good notes along the way and recording any questions that you might have for later. So to begin, we're going to go ahead and start graphing our inequalities from this system. I'm going to start off with y minus 2x greater than or equal to 1. And I'm going to get this in slope-intercept form just because it's a little bit easier for me to kind of pick through and graph it. So I'm going to add 2x to both sides to clear. So now we get y is greater than or equal to 2x plus 1. So the 1 tells me that I have a y-intercept at 0, 1. The 2, I like to see the rise and the run clearly, so I'm going to change this into its fraction form, so that becomes 2 over 1. That tells me to go up 2 to the right 1, and I can continue to do that until I get enough points that I'm comfortable working with. And if I want more than this, I can actually go in reverse. So instead of up 2 to the right 1, I can go down 2 to the left 1. And as we can see, these points line up. Because the inequality that I'm working with has an equal sign underneath it, that tells me that my line should be solid. The next thing that we want to note is we need to decide which way to shade. So I'm noticing that the origin is a point that is open to use. It's not existing on the purple line that we just drew. So I'm going to use that as my test. So we'll reproduce y minus 2x greater than or equal to 1, substitute the point in for x and y, and then we're going to clean up the left side. 2 times 0 is 0, and then 0 minus 0 will also result in 0. So we have a statement that says 0 is greater than or equal to 1. And as we say that, hopefully we're like, nope, that's false. So that tells me that I should shade on the left side of the line. So we'll go ahead and we'll add that coloring in. Okay, so now we're going to repeat, and this time we're going to look at our second inequality in our system. So we have y minus 2x is less than or equal to 3. Again, I'm going to get that so that it's in slope-intercept form. So by adding 2x to both sides, I end up with y is less than or equal to 2x plus 3. I'm able to call out, first off, that my y-intercept is going to be at 0, 3. It's a little hard to see, but hopefully you can see that green dot that just appeared. And then again, my slope is going to be a rise of 2, or going up 2, and a run to the right of 1. So up 2, right 1. I've run out of space, so I can go in reverse. Down 2, left 1, down 2, left 1. And if I connect these points, again, making that a solid line, because we are working with less than or equal to, we create that line. So in section 3.1, hopefully you recall, well, parallel lines, if we are working with equations, result in no solution. But note here, the difference is we're working with inequalities. So we want to note that while the lines don't intersect, perhaps their shadings will overlap. So again, I'm going to pick a different test point. You can, of course, work with the origin if you would like, because notice that it does not touch or exist anywhere on the green line that you just drew. Just to be a little bit different, I'm going to pick point 2, 0. So I'm going to test with that one. Again, just because it's a point that's definitely not on the green line that we just graphed. So again, working with my original equation, I'm going to substitute 0 in for y, and this time 2 for x, just because that's the point that I picked. 2 times 2 will be 4, and then 0 minus 4 will result in a negative 4, with a final statement that says that negative 4 is less than or equal to 3. That's true. Negative 4 is smaller than a positive 3. So that tells me that I should shade on the right side of the green line. So let me go ahead and pull that in for you. So again, we want to look to see where the overlap is happening. And it actually looks like our overlap is happening right in between our green line and our purple line. So I'm going to highlight this with some pink. So our solution is actually sandwiched in between our two parallel lines. Kind of made a mathematical Oreo here. Okay, so we're going to move on to the next problem. So this one's a little bit different in the sense that now you have 4 items in your system as opposed to 2. To kind of begin to help us work this out, let's focus on actually the x is less than or equal to 0 and the y is less than or equal to 0. We're going to use these just because they're a little bit lighter. So if I start off with this one and say I just replace the inequality with with an equal sign, I get x is equal to 0. And if you recall, this is a vertical line. So I'm going to highlight where that vertical line actually is. It's happening right on top of your y-axis. Because if you notice, if you pick any point off of the y-axis, the x value is guaranteed to be 0. Likewise, if we take a look at y is less than or equal to 0 and just replace that with an equal sign, we note that we have a horizontal line here. This one, you might be thinking, is it resting directly on the x-axis? That would be correct, because any coordinate point that we pick off of the x-axis is automatically going to have a y value equal to 0. So the reason why I'm showing you this is because we're starting to hone in where our shaded regions are going to overlap for all 4 of those inequalities. So for x less than or equal to 0, so focusing on that vertical blue line, I know that my shading is going to happen in the second and the third quadrant. These are where all of my x values are going to be less than 0 or negative. Likewise, if we look at the inequality of y is less than or equal to 0, so that purple horizontal line, all the y values that are smaller than 0 are going to be located in the third and fourth quadrant. Where are you seeing overlap right now? Hopefully you're saying in that third quadrant where you kind of have that hashing going on. So what I want you to note is that our solution to this particular problem that we're looking at is all going to live in the third quadrant. Nowhere else, as you can see, just by working with those 2 inequalities, nowhere else are we seeing an overlap. So I'm going to go ahead and put that red line back in so that we have that boundary. And I'm going to go ahead and clear out all these arrows so that we have a clear working space. But just know that my solution, where all my shading is going to happen, it's going to collect in the third quadrant. So now let's go ahead and work with our first equation. So we have 4y minus 3x less than or equal to negative 12. I'm going to get that into slope-intercept form. I think by now we're pretty much pros at this. But we're going to add 3x to both sides, and then to get that y all alone, we're going to divide each term by a 4. So we get y is less than or equal to 3/4 x minus 3. So we know that we have a y-intercept at negative 3, and I can go up 3 to the right 4, or I could go down 3 to the right 4. And I think for me right now, 3 points is enough. It's a safe bet. And again, since I'm working with an or equal to option, I'm going to work with a solid line here. Now we have to decide where to shade. And again, hey, that origin is not existing on that green line, so I'm going to work with that one. So we're going to test with the origin. So coming back to my original problem, or my original inequality, I'm going to sub 0 in for y and for x. Multiplying by 0 is going to result in zeros. 0 minus 0 is 0, and we end up with the statement that says 0 is less than or equal to negative 12. And right away I'm going to go, no, that's very, very wrong. So I know that this is false, so that tells me that I should shade on the side that does not contain the origin. So let me go ahead and add that in. So what I want you to know here is that I only put the shading in the third quadrant. And again, that's because, as I had previously said, when we were working with our x is less than or equal to 0 and our y is less than or equal to 0 inequalities, we knew that the shading or the overlapping that would happen for them was going to be in the third quadrant. That tells us that any other shadings or overlappings are also just going to exist in the third quadrant. I could have continued to shade the green over into the fourth and a little bit on the first quadrant, but that's not where any of my answers are ultimately going to be, and my goal right now is to not overwhelm my eye with too much color. So now I'm going to go ahead and move on to my second inequality. So we have 4y plus 3x is greater than or equal to negative 36. You know what I'm about to do. I'm going to get this into slope-intercept form. Divide both sides by 4 to clear it out. And now we're going to have y is greater than or equal to negative 3/4 x minus 9. So again, I have my y-intercept at negative 9. So that's about here. And then this time I'm going to go down 3 to the right 4. Or, yep, to the right 4. That's about right. And I can also go up 3 to the left 4. And again, solid line. Now we need to decide which side to shade of this for this navy blue line. Okay, so again, what we're gonna note is that this origin is free to use. It is not touching your navy blue line at all. So I'm gonna test with it. So going back to my original inequality, I'm going to put 0 in for y, 0 in for x, 0 plus 0 greater than or equal to negative 36, or if we add that up, we get 0 is greater than or equal to negative 36. This checks out. So let's go ahead and add that color, and again, I'm just going to keep it local within the third quadrant because I know that that's where all 4 of my overlaps are going to happen. None of the other quadrants are going to contain all 4 of those overlaps. Okay, so now we see our answer is actually located in this triangle that's been formed. So here's a boundary, and then here's that other boundary. So I've created this triangle. And again, I know, one, that I see my green and my yellow are overlapping, and again, my 2 inequalities for x is less than or equal to 0 and y is less than or equal to 0 is all going to be living in the third quadrant. The other part of this problem, so the final part, is we want to find the coordinates of any vertices. Remember, vertices are going to be the points of intersection. So right away, I can tell you, well, I do have a vertice here. That's going to be at point 0, -3. I do have a vertice here. This is at point 0, -9. I do have a vertice here, and it may or may not be easy to see. So here's where some algebra can come in. So I'm going to scoot this up just a little bit so I have some space to work. This is the intersection of your two lines. So of your navy blue line, 4y plus 3x is less than or equal to -36. And then your green line of 4y minus 3x is less than or equal to -12. If you notice, we're looking for a point of intersection. We could use substitution or elimination to make sure that we pinpoint the exact point of intersection. So in order to kind of save a little bit of confusion, I don't want to work with the inequalities. It's a little bit cumbersome, or it's a little bit hard to kind of switch back and forth. So I'm just going to, because I'm just looking for a point of intersection, I'm just going to make those equal signs. But notice what we have now. I'm going to choose to use elimination just because I'm seeing that I have a positive 3x and a negative 3x already established for myself. So if I clean this up, I end up getting 8y is equal to -48. We can divide both sides by 8, and we get y is equal to -12. Nope, sorry, that's wrong. Calc error. We are going to get -6. Okay, so we have the y portion of our coordinate. Now what we can go ahead and do is we can plug that -6 into either one of our original equations. So I'm just going to opt to maybe work with the 4x minus, or sorry, the 4y minus 3x is equal to -12. So we'll go ahead and we'll put that -6 in. -6 times 4 is going to give you -24. We'll add both sides with a 24 to clear it. That's going to give us -3x is equal to +12. We'll divide both sides by -3, and we see that x is going to be equal to -4. So our other point will be -4, 6. And hopefully we can kind of see that in here. Again, this one we ended up getting nice values. Not every problem is going to give you nice integer values. You might get decimals or you might get fractions at your point of intersection. So if we look at this one, so -4, so that's about there, and then -6, this is about here. So my rough-handed drawing actually does pretty closely pinpoint that -4, -6. So your final answers for the vertices will be -4, -6, 0, -3, and 0, -9. They don't need to be written in any particular order, they just need to be listed out. I know this video was long. Hopefully everything was explained clearly, and again, if you do have questions, please let me know.